Well, thank you, everybody. We're actually going to start out with a little bit of audience participation here. All right, so you've got a meteorologist up here. I've got to ask, how many of you raise your hands if you think meteorologists are right at least 20% of the time? Raise your hands if you think we're right at least 20% of the time. Come on, I set a low bar, right? All right, keep your hands up if you think we're right 40% of the time. All right, 60%, 80%, 100%. Thanks, Mom. Appreciate that. So the idea behind this line of questioning is that weather is complex and it impacts energy and utilities. So you want to do everything in your power to stack the odds in your favor when it comes to weather. I'm going to say it, you can't avoid weather, but you can't steal its thunder. So we want to do what we can. And so starting out just with why does weather matter to our industry here? First of all, there are storms. They cause power outages. You want to be able to prepare for, staff up, know when and where weather's going to happen. And then also know where did the weather happen? Where do we have outages? Where could we have intersections of weather and utility assets? So that is one reason why weather matters. Another is temperature extremes. So load forecasting, it could be heat, it could be extreme cold, but ultimately it impacts the industry as a whole. Flooding, infrastructure risk. So, you have rainfall that will wash out the soil around a pipeline and potentially cause a breach. So, any damage to existing infrastructure is very important and costly, and you want to do everything you can to avoid those negative consequences. And then, how many of you are in renewables here or deal with renewables in any aspect? Okay, a few of you. That's good to see. And so there are various weather elements that impact that as well. Wind, snow, if you think of wind turbines and solar panels, sky conditions, things that can affect renewables. What am I missing up here? What do you all deal with from a weather standpoint? Feel free, raise your hand, shout it out. What am I missing up here? Is there anything else? Rain. And how does that impact what you do?
The amount of rain.
Yep. Okay. Anything else? Any other weather scenarios that impact you?
Cloud cover in general.
Lightning, cloud cover in general? Absolutely. What was that? Yes, exactly. Okay. So, we've heard a number of different scenarios where weather has an impact on our day-to-day operations. And there are challenges when it comes to dealing with weather. So one of those is there's fragmented weather monitoring systems. How many of you have an app on your phone that has radar or weather on it? Probably most of you. Yeah, it looks like most of you. Those are always great sources to make decisions when it comes to what you do in your day-to-day job. That's great for your general, what do I wear, for the day, and, is it going to rain on my kid's ball game, things like that. But you don't want a scenario where within the same company or even the same business unit, you have people with different weather sources all trying to make the same decision with different sources. So that's a challenge. That's a problem. Also, manual workflows. Is there anyone in the audience here whose sole job is to monitor the weather? I'm a meteorologist, and my sole job isn't to monitor the weather. So, we're all challenged with different things. We're all asked to multitask. And so what we want to do is, weather is going to have an impact. We want to make sure that we don't lose sight of that. So that's a challenge as well. Subjectivity. So I like to give this example. So I was born and raised in Cleveland, Ohio. All right, love it. And now I live in Alabama. All right, that's kind of what I figured. I will say that 2 inches of snow in Cleveland, we just go about our day-to-day lives. 2 inches of snow in Alabama will shut down the city. Literally, they just shut everything down, and usually within 24 hours, it all melts away. But everyone's got different backgrounds, different experiences. Depending on the day, you may think, maybe that was enough wind to cause a problem, or maybe enough rain to cause a problem, but I don't want to deal with it. So you don't want to deal with subjectivity. You want to have an objective method. And then lastly, all the regulations that are out there today that you must comply with, it's difficult. You need to work smarter, not harder. So you want to use technology to help you when it comes to overcoming these challenges. So enter GIS. All right, so you're already using GIS for many, many different roles, many capacities. You have potentially lots of things mapped in there. You do your asset tracking, maybe incident response and compliance and things like that. And GIS is the perfect platform to have weather integrated into everything you already have in there. It's a living, breathing thing. Weather is always changing, even second to second. The atmosphere is a dynamic, fluid environment. And so you want to use weather and have it in your GIS to make and enhance your decision making. So the objectives of this session are to, this is kind of a best practices when it comes to incorporating weather and GIS. So understanding the types of weather that is available out there, the sources, the delivery mechanisms, and what do you need to pay attention to when it comes to deciding how to bring weather into your GIS and how to use it. We're also going to go through a number of different of Esri's tools for real-time workflows and talk about how you can use some of those towards best practices. Also just build a framework. So what are the logical steps you should follow when it comes to integrating weather with GIS? And then also, the whole goal is improving efficiency, compliance, and avoiding, minimizing risk. So that's what we're going to review today. So there are different types of weather data. There's real-time information. So, there are instruments that are measuring temperature and, radars that measure precipitation and things like that. And that's very valuable. Again, weather's always changing. You want to keep tabs on that. And you want data available everywhere. You don't want to rely on an observation that's, just at the airport. You have assets that are in areas that probably aren't very well measured. And so you want to have data that's available everywhere where you are charged with protecting assets and personnel. And then there's also forecast models. So you want to prepare for weather. You want to make sure that you're able to minimize that risk. And when it comes to forecast models, there are two ways that those go wrong. Because forecast models aren't perfect. I'm always going to have a job because they'll never have forecast models right. Number one, it depends on having that most accurate initial state. So you need to have an accurate starting point to even project forward and see how weather is going to impact you. And then the second element is the model physics. There's still a lot we're still learning about the science, and so what we want to do is always improve that and have the best physics to move that forward. And then other types of weather for GIS, it's alerts and warning. And so we're going to talk about GeoEvent Server and Velocity and using those as well. I've got a picture of radar up here. This is a feed that my company offers. It does differentiate between precipitation types. We started out with 2 talks on LiDAR. Did you know that radar is actually an acronym as well? Does anyone know what it stands for? So LiDAR is light detection and ranging. What's radar? Radio detection and ranging. All right, very good. A lot of people don't realize that's an acronym, but yeah, so we're going from LiDAR to radar. So what are the types of characteristics that you want in your GIS weather data? Well, number one, and I hear all the jokes, oh, you're a meteorologist, you get to get paid for being wrong most of the time. I've heard it all. accuracy. Obviously, you want something that is very accurate. In this example here, I've got two different radar feeds on here. On the right side, we have a public feed, which has all the ground clutter. You're seeing a lot of things that are not actually precipitation. On the left side, we have a cleaner feed that's been processed in real time. So what you want accurate data. So number one characteristic. And I was talking about this earlier, full geographic coverage. So you don't want to rely on temperature information that's miles or at a different elevation, because that can play a role in temperature, for example. You want to have data wherever you have assets. Ideally, you want the analysis already performed. And so there are some weather data sets that are out there, and I'll go over that here in a little bit, that analyze and break the weather down into individual components so that you don't need to be your own meteorologist. You can have the analysis already performed. Frequent updates. Storms, especially severe storms, move at a very rapid clip, sometimes 70, 80 miles per hour. You want data that's always updating so that you know where the weather is now. And then reliability is always a factor. When the weather is at its worst, that's when you need the data the most. And that's also when everyone's going to those public sources for information all at the same time, all at the same place. And those public sources are prone to outages and latencies and things like that. So these are just general characteristics that you want to judge your weather data by. So this is an example here of how weather can be broken down into individual elements. So we start out just with the radar and watches and warnings that needs interpretation. There are individual layers such as hail swath that update every 5 minutes, showing you where there's hail. So if you have solar panels, that's important. This is damaging wind. Notice that damaging wind, where it actually happened, it takes over a much smaller area than the warned area in that red polygon. And then flash flooding. So where can we expect flooding that can wash out that infrastructure? So you go from this image here that requires analysis and interpretation. Most people know, you look at those reds and purples and you know something bad is happening, but what is it? Is it heavy rain? Is it damaging wind? Is it hail? So you want to go with a weather service that is doing that analysis for you, so that you don't need to be a radar expert. Some Esri tools that are used. The company that I work for, we are an Esri partner. And so you want to have a source that's going to work across the entire Esri ecosystem. So, Pro for your desktop solutions, online if you're SaaS and in the cloud there. How many of you, does anyone here use Geo Event Server? Okay, I see a few hands. What about Velocity? Not yet. There's one there? All right, perfect. So Geo Event Server and Velocity, in spirit, they do similar things. It's for real-time workflows and notifications. So I'm going to show an example here in a little bit, because there are kind of three different things you could do with weather and GIS. You can map it, visualize it with your assets overlaid. You can create dashboards that will quantify what that problem is. So how many assets do I have that have experienced wind speeds above this threshold or rainfall above this certain amount? And then that highest level is the alerts. So actually using that information in an automated fashion to generate some workflow that's going to help you in the decision-making process. So I mentioned dashboards, being able to quantify what the problem is. These are great. They provide a single pane of glass, a high-level overview that you can share within your organization or even outside of your organization too for public consumption, that will kind of give that high-level overview of how weather's impacting your organization. You want updating in real time and accessible by those in the field. So yes, you can have it in an operations center, but I'm sure many of you have people out in the field. You want everyone working on the same information, whether they're in the office or not. And so these dashboards are very powerful for quantifying, what exactly you're up against. In terms of web maps, situational awareness. So This is a field right here of wind speed, and because it's in GIS, you're able to filter out any wind speeds that you don't care about. So for example, if you are only concerned with wind speeds above 20 miles per hour, the fact that it's in GIS means that you can do all those fun GIS things, filtering and things like that, and of course overlaying with the assets. And so that is another great use. So dashboards, web maps, and then the real-time notifications. So Velocity is the cloud-based version of real-time notifications that Esri provides. And so it's great for analysis, for implementing a workflow. Even better, if you have a source in there that has a branded connector, that makes it even easier to drop and plug and play with the data in Velocity. And so I'm going to give an example here of using wind speeds at wind turbines and cranes as well. So I'm going to show you, take you step by step. So the first step in Velocity is that you create a feed. So this is data that you have, and then also weather data as well, because ultimately what you want to do is tie those together. And then you select your data. In this case, there's a branded connector that can be used again for plug and play. And then once you have that feed, that branded connector, you're able to go in and select the particular element in there. In this case, we're going to select wind gusts as the data layer that you're going to compare to the assets. And then you choose the spatial extent, the polling extent that is, so that you can work efficiently and only run it against a smaller area. And then this is where the fun begins. This is where you start to take what you have mapped out, wind turbines or cranes, and combine it with the weather data. And then you join the features. You do an intersect so you can see where these match up. And then you can apply filters and define an expression. You could do like a simple arcade expression. In this case, we only wanted to see wind speeds above 20 miles per hour. And then ultimately, with Esri's ArcGIS Velocity, you're able to, they have Slack and Teams integration now. You can also send a custom message via text message or email. So it's a powerful tool to allow you to work quicker and more efficiently and objectively. And so this is an example of, someone at that spot receiving notification that this asset has experienced wind speeds above 20 miles per hour. So a very powerful tool to take weather information, combine it with GIS to analyze the situation and take action. The benefits of this, of course, are faster decision making. So you want to be able to, again, work smarter, not harder. You want to reduce manual monitoring, have everything available in an automated fashion. You want to be proactive. You want to comply with regulations, and then, of course, you want to enhance your coordination with your field teams. So just kind of that workflow, again, identify the relevant weather layers, connect to a real-time feed for weather information, real-time forecast, and then configure it. Potentially different divisions within your company may have different needs, so you can make it apply to those situations, whether they're more concerned about wind or rain or lightning. Configure it towards the task at hand. And then make sure that you're aligned with the regulations that are out there today. And the result is that you're going to be prepared. You're going to minimize the impact. You're going to be more efficient. There's a cost to over-preparing and under-preparing, right? So you want to be as efficient as possible. And of course, honestly, number one, safety. You want to keep your personnel out in the field safe. So that's kind of a quick run through of how to use weather data and GIS together, some best practices. And so I'm definitely open for any questions. So thank you for your time.